Disaccharide. Okay, di means two. Okay, miss an S here. Disaccharide. Okay, it's correct. Two. So it has two monosaccharides. Correct. Two monosaccharides. So they will give you an example here. If you have a glucose plus glucose, what do we get? It will form maltose and water. Remember we talked about dehydration and hydrolysis last time. I also give you a brief review at the beginning of today's lecture. So dehydration is a synthesis process that make polymer from monomers. So the polymer, or we call disaccharide, is maltose here. It is made of two glucose. So the question for you is that where can we find maltose? Where can we find maltose? Well, I hope you remember. I hope you know that maltose. One of the examples that we can find, we can have maltose in our daily life is beer. Beer contains maltose. So this is something that I want you to memorize. This slides. Maltose is equal to glucose plus glucose. Sucrose is equal to glucose plus fructose. And then lactose is equal to glucose plus galactose. So I want you to memorize this. It's like an equation. Maltose equal to glucose plus glucose. Sucrose equal to glucose plus fructose. Lactose equal to glucose plus galactose. So I already told you that maltose, you can find it from beer. It gives you another example here. You can find maltose from caramel sugar. Sucrose, well, is an example of table sugar, sucrose. Lactose, well, you can find from milk. So, anyway, I'm not asking how many of you have a lactose intolerance. I'm asking how many of you know what happened or what causes the lactose intolerance. Well, let me explain it to you right here. What happened is that when we were kids, our body makes an enzyme called lactase. When you see the suffix ase, so remember OSE means sugar. What about ASE? ASE means enzyme. So this is something that I also want you to memorize. It is helpful for the rest of your life if you continue to study more biology or physiology. So, as the name suggested, take a guess. What does this lactase enzyme do? Yes, this lactase enzyme breaks down lactose into glucose and galactose. And for some interesting reason, our body, our small intestine, can only absorb monosaccharide or monomers. So, when the enzyme lactase breaks down lactose into glucose and galactose, then our small intestine can absorb them. As we get older and older, as we drink less and less milk, our body will also stop making the enzyme lactase. But then one day you decide to drink some milk, or you want to get some pizza with a lot of cheese on it, then what happens is that your body suddenly have the lactose in the body, and your body does not have, or your body stop making lactase. So what happens is that this lactose molecule will go through or bypass the small intestine, because the small intestine cannot absorb lactose. Lactose is a disaccharide. So the lactose will go through the small intestine and then go to the large intestine. What do we have in the large intestine? The large intestine has bacteria living there, and when usually the bacteria eat our leftover food, meaning the things that we cannot digest, then they will process it. But this time they have the lactose sugar. Well, to them, lactose is like a gourmet food. They don't have such a good thing to eat. So what do they do after they eat? Well, I'll say, what do you do after you eat? Well, the correct answer is that after bacteria eat, they will go to do number 2. So, but the number 2 the bacteria produce, they are gases like CO2 or whatever gases, or methane gases, and they will produce acid. The gases that the bacteria in your large intestine produce will become the gases that we have during the lactose intolerance. And also the acid that they produce will irritate our bowel. The irritation caused by the acid will cause the large intestine to stop absorbing water. Normally, our large intestine will absorb lots of water, but because you have irritation or the presence of acid in your large intestine, so your large intestine wants to get rid of the irritation by flushing it out. How do they do that? They stop absorbing water so that the large intestine will have more water in it. And when your large intestine has more water in it, then it will become diarrhea. That's why lactose intolerance, one of the symptoms is diarrhea. Is that clear? And other carbohydrate, I would say disaccharide. Disaccharide, sucrose, there are table sugar, I already mentioned that. Maltose, caramel sugar or in beer. And then lactose in milk, we already talked about them. Okay, let's talk about carbohydrate. Carbohydrate, they are a long polymer that contains many glucose subunits. So it already tells you that monomers going through, if you connect all the monomers here, and then you become a long chain of polymer. They use the word polymerization. Basically, it's a fancy word for dehydration. What it means is that polymerization is basically you have a lot of dehydration process together. When you have a lot of dehydration together, that means you will join all the monomers to form a polymer. So that is basically a polymerization. Polymerization is basically a lot of dehydration processes together. Polysaccharide is a long chain of polymer. Okay, glucose. Okay, starch. Yeah, okay, this is important to know the differences. Starch is the storage form of glucose in plants. So an example, okay, you have all these are the example on the picture. In the pictures, you have a potato, you have a flour and stuff. Let me give you an example. I'm a Chinese, so I eat rice. I did this many times, so it works. Trust me. So when you by any chance go to a Chinese restaurant and then you order steamed rice, you can try it as well. You chew rice but this time you chew rice longer than usual before you swallow it. You will keep chewing the rice in your mouth instead of swallowing it, you will feel sweetness in your mouth. Why? Because in your saliva we have an enzyme called amylase. Again, it ends with the suffix ase, that means it is an enzyme. Why do we call amylase? Because starch has another name called, guess what? Amylose. Amylose. So starch has another name called amylose. So amylase is an enzyme that will, guess what? Amylase is an enzyme that will break down amylose. Yes. Think about this. If starch is a storage form of glucose, that means starch is made of a lot of glucose joined together by polymerization or a lot of dehydration processes together. When we break down starch, what do we get? When we break down amylose, what do we get? We'll get maltose. Okay. That's why we taste the sweetness. The sweetness comes from maltose. In order to have this reaction, meaning that from amylose to and we call this breaking down into maltose, we call this hydrolysis. I hope you still remember hydrolysis. We need the enzyme amylase, but we also need the relatively elevated temperature. So in our mouth, it should be around 37 degrees Celsius. Maybe it is a little bit lower, but you can assume that in our mouth it is also 70 degrees Celsius. So the slightly elevated body temperature than the surrounding or room temperature, 37 degree, and the enzyme amylase together will be good enough to carry out the hydrolysis of amylose into maltose. Starch is a mixture of amylose. See, I told you. Starch is a mixture of amylose and amylopectin. Well, it said that amylose is a non-branched. Amylopectin, they are branched, but that's okay. Basically, you just know that, okay, starch is lots of glucose connected together, and then starch has some branches, not a lot, but some branches. It forms some branchings.